inflation and real rate of return. This title might seem familiar to you because we did the exact same thing in shares. We've already discussed inflation is the constant increase in price over time. We did it in shares. Why? Because investments take time. So if you're aiming to purchase something with your investment earnings, you have to consider that the price of the thing is going to be more later. We must consider inflation with investments exactly the same way. If you don't have this formula already, can you please get it down? It's the value index. It's the inflation formula. I'll give you a minute or so. Can you get the inflation formula, although you would have it for shares? We are doing the same content for shares, but in a different context. Inflation and real rate of return. The maths is exactly the same. All right? So can you get that in pink, please? The formula, value index for inflation. Original value times by 1 plus I to the power of n. I is the inflation rate as a decimal. N is the number of years it inflated. We'll do an example after that. Do you want it bigger?
Does that say after original value times, in the brackets, does it say 1?
1 plus I, and then as to the power of n. After I've done this first lesson, I'll sit down with you and tell you like next steps. Okay? Because what you could do is if you do all the maths, then that stuff you called BS before, you can write that after. Right?
So just get through this first.
Yeah, and then I can check it. Because it's easy. Once the maths is there, you can see what you need to say. What if like I'm waiting for them to do the notes, go show me how much interest you would save by choosing to pay $100 more per month, $150 and $200.
It's just textbook questions, really.
Yeah, but you're showing it in context. Yeah. And then you compare it to your default. All right, Georgia. Georgia wants to buy a painting for $5,000. She can't afford it right now, so she's going to deposit money into an investment account so she can buy it in 3 years' time. What's the problem with that? The price of things goes up over time. So we have a formula here. If inflation averages 2.5% per year, what's the painting going to be costing in 3 years' time? So value indexed for inflation is going to be, what was the original value of the painting? $5,000 times by 1 plus, what is the inflation rate according to the question? Yep.
0.02.
Good, because it needs to be a decimal, and I'm raising that to the power of, how many years was it inflating for? 3. Chuck that in your calculator. Your graphics calculator can be trusted to do bed mass properly. So 5,000 bracket 1 plus 0.025 end bracket. The power button is this little, we call it the hat symbol in maths, but it's like a chevron pointing up. It's like a little line there. You can see it made it a power to the power of 3. So what that's telling me is that painting will be worth $5,384.45 to 2 decimal points in 3 years' time. Why is that important to consider? Well, B, she's investing in an account paying 3.5% per annum, compounding monthly. How much does she need to deposit monthly? Can someone remind me, how do I access TVM Solver? Yes? Apps?
Finance. TVM Solver.
Good. The investment account is paying 3.5%, so 3.5 for I. Does it say she's putting a chunk in to start off with? No, she's just putting money in monthly. So we're going to solve for PMT. This is where the inflation thing came in. Because if I said FV is 5,000, compounding monthly, 12 and 12, 5 years, so 5 years happening 12 times a year, 60. If that's what I set up the account to be, is she going to be able to buy the painting after, 3 years. It would have been 3 times by 12. 3 times 12, 36. If we set up the account to do this, is she going to be able to buy the painting?
No.
No. Why?
You're not actually putting anything into the account.
No, well, we haven't solved PMT. What I'm saying is, okay, sorry, we'll find PMT. Alpha, enter. If she put $131.93 into the account every month, what is the account going to end at? 5,000. Is she going to be able to afford that painting?
No.
Because the painting in 3 years is going to be worth $5,384.45 instead. So what do I need to change in the TVM solver to make sure she can actually afford it?
Well, FV index for inflation.
So FV is going to be 5384.45 because you're using maths to predict what the painting will cost later. So now if I solve for PMT, that's telling me I'm going to have to put away $142.07 to actually be able to afford the painting. So your working out should look like this. 36, I is going to be 3.5, PV, she started off with nothing. Put the star, I'll put the stars here, PMT, negative 142.07 to 2 decimal points. So $142.07 per month. FV is going to be $5,384.45. PY is 12 and CY is 12. That is the example for Georgia. Please get that down so you can apply it when you do the exercises. I have another lesson after that, so I'll stop the recording there.